All right. So why don't you go ahead and introduce yourself and introduce the talk for the benefit of future viewers of the Q&A video.
I forgot what the title is. So
D for the 21st century, moving fast without breaking things.
Right. So yeah, my name is Átila Neves, co-leader of the D programming language, moving fast without breaking things, D for the 21st century. I did this talk based on basically the evolution of the D language and what I think is important going forward, what isn't, etc. And we can't afford to stand still, and what I'd like to see going forward, that kind of thing.
I have a few questions for you about this talk. I mean, first of all, you mentioned that you were going to talk about something else, but you decided not to, and then you decided to talk about this instead. So I'm curious, why this? Why this topic? Why now?
So what happened was I was talking to Walter, and I didn't really know what I was going to do the talk about, and then I ended up coming up with this idea about terrible features that are being implemented in non-joke programming languages, because obviously, there's so many meme languages that those don't count. And I was going to do that and even posted on the forum asking for ideas, and I just didn't want to do that talk. I kept procrastinating, and I just listened to myself, basically. My brain was telling me that I didn't want to do it. And I kept pacing around my flat and ended up thinking about this. I guess I was chasing my passion. So I was like, what really moves me? And that just came to me, and I went, and then started writing. Whereas I'd been, procrastinating for 2 days, didn't even get a slide really done. And then this just kind of flowed out. And yeah, just that's what drove me. That was the passion I had at the moment, and I really want this language to do well and succeed, and that's what I ended up writing about.
So, I mean, was there any motivation from some of the forum discussions going on these days?
No, not really. It just kind of came from me. It's basically me trying to find my own passion in the D community and the language itself, and something in my subconscious, basically.
Your title includes the phrase without breaking things. And, this is something that in the community, you hear some people say, please break my code. I want you to break my code to change this or change that. Other people say, absolutely, no way, you can't break my code. And you put a path forward for code breakage in the form of possible epochs or
additions.
Yeah. But I wonder, where do you see the dividing line for saying, okay, this is minor breakage, we can go ahead and include it in the current version of the language, or, this belongs in a new addition or epoch? I mean, on one end, you have like the Java extreme, where they were so tight about not breaking code that deprecated features were never removed, right? And nothing changed really until I think Java 9 was when they started finally doing that. So, I mean, if you look at one extreme, you have like people using the language, they're relying on bugs, the behavior of bugs, right? Or features that aren't working the way they're supposed to, and they rely on this faulty behavior. Okay, is that worthy of a new addition, or can that kind of breakage go into the current version?
I think that's always worthy of a new addition of thinking about backwards compatibility, because one phrase that I learned about when I was working at Cisco, because I worked with one of the guys that was a Java developer actually, and he worked for Sun back in the day. And for me at the time, it was hilarious that he had the hand in shaping the standard library of Java. I'm like, oh my God, this is amazing. Somebody who can actually shape the future of a standard library of a language, and I'm working with him. And years later, here I am, Phobos and all that. But and at the time on LinkedIn, he had a referral. No, what do you call it? Like when somebody basically said that, yeah, I know that this guy knows this thing. So James Gosling was saying he knows Java. I'm like, wow, that's interesting. And he introduced me to a phrase which was bug compatible, because when people try to do rewrites, it turns out, like you said, people depend on the bugs, and you have to be bug compatible with the old version. And there's been several rewrites of software projects that just don't work because they're not bug compatible. And I think that it's really important to keep that in mind with backwards compatibility and the whole theme of the talk. So that's something you need to think about. With regards to your question of, where do you draw the line? I think that goes back to what I call my rule zero of programming, which is always use your head. Like, think about things. Don't, there's rules of thumb, but think, understand the trade-offs and then make a decision. That's why we get paid the big bucks. So it would have to be on a case-by-case kind of thing. I don't think there is anything I could say in general, any kind of guideline. There would have to be, what do you think about this? And you have to think about it and then make a decision about that specific topic or feature or what have you.
We have this situation now where, old D code doesn't compile today in a lot of cases. We've already gone through this, and mostly it's because of these little changes that I mentioned. But so you're telling me you want to completely eliminate that. So
yeah, I want to first to be in a world in which old code always compiles, but that at the same time not holding us back from making significant changes and going into the future. Yeah, that's what I want for this community, for this language.
Yeah, I think that'll make definitely some people pretty happy. But I know Funkwerk is I believe they're one of the ones who say break my code.
Yeah, they are. Yeah. But as I mentioned in the talk, the problem with that is you get, one user of D saying, break my code this particular way, but not other ways. And then somebody else obviously will have different ideas about what's breakable or not. How do you make everybody happy? Well, the short answer is you can't. But
which language do you think handles, which languages do you think handle that really well right now besides like C++?
Well, I was going to say C++, obviously, because I think, their example is, again, there's a reason why I mentioned in the talk too. Their whole message, their whole value-added kind of thing was, adopt us, it will be fine. You risk nothing. You can just include things, and there you go. Hi, Walter.
So standard experimental, that's what you're on right now. And you talk about it's not doing what it's supposed to have done, because it's where things go to die, you say. And that is basically true. And I think, the reason is we just never established the process to move things out of it. We didn't establish any kind of procedure. We just said, hey, let's create this experimental package and start throwing things in it. But we never discussed how to bring things out of it specifically. So you suggest that a better option might be just putting new potential Phobos packages on code.dlang.org. Just throw them in the dub repository, let people use them, put them through their paces, and then eventually create a process to bring them into Phobos. Can you explain?
SumType did that, and I think it was really successful that way. We went through several iterations. People submitted issues. I did pull requests, that kind of thing. It's just a lot more agile, because if something gets into Phobos, it's a bit like molasses. I mean, for good or bad, it is the way it is. And so I think that we need to encourage that more. It's like, I think this should go into standard library. Well, maybe create a dub package first, have people use it, have people comment on it. Because at least there you have semver, so if you do breaking changes, that's fine. And the old versions are there, and you can still depend on the old versions, you can pin. And, maybe it goes into Phobos later. I agree with Andrew that we should have included batteries, but all of the batteries, even the weird formats that you have to go out your way to find, maybe not. Again, balance what goes in, what goes out, case by case. Robert mentioned in YouTube why set and so bugs are fixed all the time. Yes, bugs are, which is good. I mean, if they weren't, it would be very, very bad. But a lot of things get stuck though, like especially bad decisions. Cough, auto decoding. So,
Walter, I think this question is for you. Parthenarx asks, this is not related to Átila's talk. It's about ImportC. And by the way, that's Walter's talk tomorrow. So Parthenarx asks in the live stream, what's the long-term plan for ImportC regarding pre-processing? Will it be integrated somehow? You talk a little bit about that in the talk, didn't you, Walter?
Yeah.
Yeah.
Not a whole lot. The thing is, it's we don't really know what to do yet with the preprocessor.
Okay.
There are several paths we can take. Integrating it is just one of the paths, but I'm not sure what the right answer is there. And my focus right now is on getting the non-preprocessor part of the compiler working at 100%. So once that's working, and then we'll kind of see how things go and what we need to do to improve it. The biggest problem with integrating the preprocessor is not the preprocessing, surprisingly, because we have a preprocessor we can integrate, the DMPP, also known as warp preprocessor. The problem is all the predefined macros that, 400 to 500 of them, largely undocumented preprocessor macros that exist in GCC and I presume Clang. And what turns those macros on and off and what their definitions actually depend on is who knows. And trying to keep up with that is a maintenance nightmare. So that's probably the biggest roadblock with integrating the preprocessor is what the heck is going on with that. It's a similar problem with trying to compile C code is all the compiler extensions, dealing with those. I know some people have already run into that problem. Which set of compiler extensions should we be supporting? And that's kind of we'll just have to see how that goes for the time being. So I don't really have a good answer yet.
Yeah, maybe you'll have one tomorrow. Sleep on it.
I'll sure think about it.
We have to support the preprocessor in some capacity because there is no C code base that exists that doesn't require the usage of the preprocessor in some way or form. Some of them are simple because they're just constants, but the problem, of course, is the ones that aren't. And the biggest problem is the ones that are snippets of code. Sorry, because, they're not valid C code by themselves, so you can't even just analyze the macro. They're only valid in context, and that is a massive problem. For instance, in Python, there's a macro to initialize some of the structs, which, of course, the macro depends on the actual definition of the struct itself, but as a human, I can tell that that's what it's doing. But how do I write a program to recognize that that macro is, please initialize the struct because it's set in zeros here and what have you. And that is a problem I don't know how to fix.
At least for the header files, when you preprocess it, those metaprogramming macros will already have been expanded. The problem goes when you try to use those metaprogramming things in your own code. That's I know you with DPP, you've worked on manually sort of doing an ad hoc rework of them. That'll work for a lot of cases, but is not obviously not a general solution.
No.
But one thing that is helpful is I believe GPP and the GNU preprocessor at least has a switch where it will dump out all the surviving macro definitions at the end of it.
Yeah, libclient has that.
Well, you don't have to build a preprocessor to extract those definitions. What you can do then is write some code that reads those macros in and then applies Átila's heuristics to it to extract things like manifest constant declarations out of it and inline function declarations. And that'll be a reasonable first order approximation to it. But generally being able to use the Boost preprocessor macro library and get it to translate to D is just not going to happen. We just have to be realistic.
Ricky said here in the live stream, we kind of need to look at allocators, like what is holding it back now?
Well, I asked Andre recently, and there's like 2 or 3 little things that he's concerned about, but they're all fixable. So what I need to do is fix them and then move it into standard.
So it's just a matter of getting the work done.
Yeah, which I will do soon.
Okay. Sounds good.
I think this needs to be a priority because, as I mentioned in the talk, I think that people need to have confidence, and we need to project that. And I think a good way of doing that is moving those things that are experimental out of experimental. Obviously, we won't break any code by doing that. The right way to do this is by deprecating those old modules and doing a public import of the new ones. So you'll annoy people, but the code will still work.
You said you want to fix those issues. Is there any way active community members can help you with that?
That's a good question. I need to actually go check the particular list because I don't remember off the top of my head. But if there is, I'll post in the forum, do a call to arms kind of thing.
The thing is, my colleague Edistan Iloyu, he used to work on the allocators and he had a bunch of issues. But I think that maybe we can discuss with him because he also has some pull requests with regards to allocators. I know that also Wilsbach worked at some point on them, and these are all pull requests in the queue. So maybe it's just a matter of reviving those.
Yeah, absolutely. Please ping me next week about all of those pull requests. Well, I'll go check them anyway.
Alexander Lopez Godoy says, can I dream with D3? The answer to that is your epochs and additions, right?
Right, exactly. So the whole D3 thing, and as I am, mentioning in the talk, is the idea is to maybe copy what Rust did and what Vittorio Romeo's proposing for C++, which is called additions in Rust, and it used to be called epochs, and that's the name of the C++ proposal. How can we make breaking changes without actually breaking things so that we can move forward without, ignoring the old code that still works? So the idea is you can dream with D3 without breaking with D2, without making, basically the mistake that Python did, because that nearly sunk them. They used to have a website called the Wall of Shame, which has all of the PyPI packages that weren't Python 3 compatible. And then at some point they decided that was a marketing blunder, so they changed it to the Wall of Awesome or something like that. But that was a big deal. I mean, Mercurial was one of the biggest projects that was stuck in Python 2 for quite a while. Don't know what happened. Don't know if they managed to migrate or not. And we definitely don't want that. So I'm trying to think of a way in which we can move forward without breaking things. I think the only real challenge there is the current code base in the compiler itself, because obviously it wasn't written with that in mind. But, maybe we can refactor it so it does work that way.
You mentioned possible future direction would be const by default. That's something you would like to see.
Absolutely.
Okay, but one thing you didn't really touch on is would it still be, would you still be looking at transitive? I mean, you would definitely have to bring in a mutable keyword for your variable declarations. But what happens if you declare a constant, a mutable member of a constant object? Do you now have a mutable object? Does mutable then become transitive?
That's a very good question, and I don't know. I mean, we have so many challenges to even get to that question. I don't even know if it's relevant.
Okay, what about safe by default? I see that you avoided the bugbear there, extern C functions. I know you've made your thoughts on that public before, but have your thoughts changed since last year?
No, not really, because I think the problem with extern C is that for most people, they immediately think, well, these functions are implemented in C, but that's not necessarily the case. You might be writing D code that calls C code that, as a callback, for instance. So why would that be suddenly not safe? And also, just because it's C doesn't mean it's inherently unsafe. It might have a safe interface to that function, As I've mentioned before, libclang, because I have a dub package for that, to wrap it in the D interface, I just went, you know what? I trust those guys. Everything's safe. It's fine. Also, everything's constant, because I doubt they're actually mutating anything under the hood. So I just decided to trust the libclang API wholesale.
In the talk chat, they were talking about standard XML and whether it should be removed or not. And Ali made the comment or the question, why not move to standard.old or standard_old instead of just removing it completely?
And I replied there, if we have versioning, then we don't need that, do we? Because it'll just be in version 1, and that's fine, and that can live forever.
And we already have undead, right? For that. That's what Walter created
Right.
undead for.
Right.
I don't know how many people are using it. The other thing I wanted to ask you about was your idea for classes. Now you are speculating about having classes require a pointer syntax, T star, and then T alone for classes would become an error, a compile error. I get two things that jump out to me about that. Is first one is we get is a positive I see. We get the possibility to declare mutable pointers to immutable class data. Right now, if you declare a constant or immutable class reference, the whole thing is
right. The pointer's immutable too. Yeah.
Yeah. So the T star gives us the possibility to use them like struct pointers, and you can have a mutable pointer to the immutable data, which is a interesting benefit of that. But on the other side, it's really jarring, I think. Is there any benefit to it beyond template codes and what I just mentioned? Because to me, if you tell, I mean, right now, the story is pretty easy to explain. You can say, oh, our classes are like Java's, our structs are like C++. But the situation you're talking about, I don't know of any analog to that in other languages.
I don't think the story changes. I think it's still our classes are like Java, our structs are C++. And
except T alone doesn't compile.
Yes, but that's the good thing, right? Because when it gets confusing is when things have different semantics, and it depends on what you wrote. If it's a compiler error, you're never going to be confused.
Okay, well, I just find it seems a little jarring, but I would be interested to see if it would work, because I don't think you're the first one to suggest that. I'm pretty sure somebody else has suggested it.
Well, I think special cases are a bad thing in general. For instance, the pointer thing that you brought up, I hadn't even considered it, and I love it when things come out like that, just because you add simplicity and suddenly there's good consequences you hadn't even thought about that come out of that.
Parthenox asks, would D3 or your epics or whatever be a continuation on D2 or a parallel entity?
I guess a continuation, because we shouldn't abandon the good ideas of the past. But again, the answer is I don't really know, because we need to decide what goes into it. Again, we're gonna make new mistakes, and we need to plan for those too. We're not gonna get it right. We didn't get it right the first time. We're not gonna get it right the next time either. And we need to iterate and continuously get it better, and hopefully asymptotically approach nirvana.
And Stefan likes the idea for star on classes. So hey.
Yeah, special cases are bad. I guess I didn't make the case well enough. I don't want to write this with a static if, but it's deeper than that, right? The fact that exists is bad.
Okay, Esne asks, how would you make sure old unfinished features would be finished?
I need to get on them. It's basically on me and Walter. Nobody else is going to do it. And we need to focus on it before we add anything else, I think.
Robert Shattuck asks, what other batteries should Phobos have included?
Good question, Robert. I don't know. I would guess that the next time we see each other, we can talk about this for hours.
Stefan asks, how about putting a bounty on the template emission bugs?
Yes, absolutely. Yeah, we should do that, because it's bad and it needs to get fixed.
Stefan, if you have any specific bugs you'd like to see a bounty on, just send me the links and I'll set it up. No problem. Okay, WebFreak. Everybody knows WebFreak from Code D, Serve D. He's asking, with const by default, did you mean fully making the language const by default? I would fear D being harder to write without an IDE then. Wouldn't the IDEs suggesting more const right now be better?
Why would it be harder? I mean, I put const by default on everything I declare. I don't find it hard. So I would ask, what's hard for you? It's not hard for me. All my parameters are in, all my variables are constant, except when they're not. But that, to me, is good, because they jump out. It's like, wait, why is this auto? Why am I mutating this?
Ethan is down with const by default, and we have real need for immutable in console gaming.
Mm-hmm.
And WebFreak says, for prototyping with D, I quite like being able to quickly write down code and not worry about stuff like const first.
Right. And again, I'd say, what makes you worry? Because I don't. I mean, I'm having difficulty understanding what the problem is because I don't have them. It's like when people say, well, safe by default is bad because I don't want to constrain myself. Constrain yourself to what? Like, why are you adding, things to pointers? Stop doing that.
Parthenox asks, could we see an immutable by default in the language, or is that too far?
It's probably too far because when I started writing D, I started using immutable everywhere because it was, I came from C++ and I was like, there's more than const. This is amazing. Let me use it everywhere. And then I found that was overly restrictive because, like I said, if you have a struct that has a pointer in it, you assign to const, and then suddenly you can't assign to immutable because now it means, because of transitivity, it's a bit of a pain. And it doesn't really value anything because what you want to say is, I'm not going to mutate this. Immutable is a much stronger guarantee, which sometimes you need. For instance, I wrote MQTT broker, and at one point I had, so the messages are basically bytes, and I had a array of bytes, so basically a pointer, and I wrote const, and the thing is, I realized later what you really want is immutable because of speed and optimizing it, I started reusing a buffer. So it's basically a circular buffer that you read the bytes that came from the network in, and you just slice it differently and started moving the window. But that meant, of course, because the first iteration of it was use the GC, don't care, allocate new memory. Obviously, that was slow. When I stopped doing it and reusing the buffer, const was no longer good because I overwrote it somewhere else in the program. I'm not going to change it here, but somebody else did. So in that case, you definitely do want immutable. But otherwise, most of the time you don't, because you're not, especially with scope, I'm only borrowing this for a short amount of time. Do I care? Not really.
Immutable is useful in a few cases. One, obviously, is if you want to store your data in read-only memory or even put it in a PROM. Another use is you don't have to synchronize access to it if you're running multi-threaded. So if you build an immutable data structure, you can share it with a zero overhead with your other threads. You don't need to lock or do nothing.
Absolutely.
Its third use is if you want to do functional style programming, which relies on immutable data structures. So you have three main uses.
Yep.
Personally, I love immutable, but I find it difficult to use it very much because I tend to write lazy data structures, and lazy data structures obviously can't be immutable. The DMD front end is very much based on lazy data structures, and trying to use immutability in it and even const has proved frustrating because of that. But to me, that only shows how strong the constant immutable guarantees actually are, because they're actual guarantees. They're not pretend const or pretend immutability. And I think that's the strength of D, that those qualifiers actually mean something, whereas they don't in other languages.
Yeah, I worked somebody the other day was asking how they use G shared, and I went, don't make it immutable if you're sharing it between threads, and if you can't make it immutable, question what you're doing.
Per Nordlo asks, what about implicit conversion to head-mutable ranges?
I have to think about that. Sorry, Per.
Yeah, I know Andre posed that on the news groups, but I don't really have an answer at the moment. I have thought about implementing head-mutable from time to time, but haven't really gone too far with thinking about that. I'd hate to rush in with something off the top of my head here, though, because I haven't really thought about it.
What's your thought on the T star for classes, Walter?
I haven't thought about it, so I don't really have an opinion on it. I'd kind of hate to give up the implicit dereference that class objects have. So that's my shallow first order comment on that.
I think another symptom of this is the fact that I've seen more than one person, including one BeerConf, and also at work in our code base, that people use classes not because they're using OOP inheritance, but just because they want a reference type. And to me, that is profoundly wrong.
Yeah, that's kind of an ouch thing when I heard that. I have thought about making ref maybe more generally available, like enabling ref members, ref fields in a struct, and ref local variables, but haven't gone too far down on that path at the moment. but it may make the at-live programming more useful to be able to have those.
Steve says, yes, please, ref everywhere. My next question was about the exceptions. You mentioned that you'd like to move to exceptionless error handling, but you didn't talk about why.
Because of the overhead. The implementation complexity of it and the way it defeats optimizations to have it is all, well, it's a large hidden cost in your code. And to me, whenever I write new code, I'm always thinking about what am I going to do with the error case. And it's a challenge to design things so that the errors happen smoothly with it and they're not hackish. But it's kind of a fun challenge to do that. Exceptions is a way to kind of not think about it, but that means you've got a lot of paths in your code that you've never thought about. And that always kind of bothers me. So no, I'm not all the way there for having instead of exceptions, do it this way. I know Herb Sutter has a great talk on doing that in C++, which I recommend. I don't remember the name of that talk. You're nodding, Átila. Have you read the paper? Have you seen it? Yeah. You remember the title of it?
I've seen the talk multiple times, but I can't remember what it's called. I actually looked it up when I was writing the talk that just happened, but I still don't remember it. I mean, if you look for Herb Sutter exceptions, I think you'll find it.
I haven't spent a whole lot of time thinking about alternatives on that because I've been focused on other things. So I don't really have a fully formed answer, except that in my own code, I try to make the error return part of the normal return from the program or from a function.
Yeah, I think the one thing that exceptions are phenomenally good at is avoiding the boilerplate of having to propagate it further. Because in my experience, most programs just, for the most part, you log exceptions. Either you print it to std out, or if it's a graphical program, you do something, a window pops up, or you have a logging mechanism, and that's where they end up. So nearly always what happens is this bubbles up to whatever your main function is, you catch it there, and then you print it. And the good thing they do about that is you don't have to keep worrying about it in all your other functions. You throw it once, and then it gets propagated all the way up to the place where you're most likely to not logging them. And languages like Go, for instance, when it's like, oh, it's great, we don't have exceptions, you always have to handle the error, but then you have to go if, and then a tuple equals function call, return error, blah, blah, blah. And that's a pain. So I think that's the one thing they're good at, is not having to worry about propagating them up, because you're probably going to do that anyway.
Nitrum X asks, what do you think about shortening the declaration of variables by something similar to Golang's colon equals in place of auto?
My answer to that is one syllable. Yeah.
Yeah, tomato.
Robert says he likes it.
Well, the thing about auto, though, is you can often just replace it with const. And if you have the colon equal, you're going to have to add const in there anyway. So I don't see it really as a big win.
Fantastic.
Of course, I've never programmed with it. Maybe I'd grow to like it if I used it.
No, you wouldn't, because Go doesn't have const. So they get away with that.
Oh, well, that's cheating.
Well, it's cheating in the wrong way as well. I mean, you're just shooting yourself in the foot. So what's the point?
Okay, we have a question from a user with the handle GoFudge, F-U-D-G-E, yourselves, asking, is dlang from Facebook? And no, dlang is from Walter. There we go. That's him right there, Walter.
dlang predates the existence of Facebook.
Yeah, by quite a bit. Here asks, could having a built-in unique type qualifier improve containers?
If you mean in the sense of not having aliases to it, yes.
Well, you kind of get that with that live programming, which only allows one mutable pointer to every memory object. So that's the way we're going, but it's not going to be a special qualifier.
Well, we'll see about that. Let's put it that way.
Yeah.
Átila, do you want to say anything before you go?
Yeah, I'm hungry. I'm going to eat.
Anything to close out your talk?
I hope you enjoyed it. And if you have any questions later, obviously, I'm on the forums and Discord and what have you. So reach out if you have anything to say, anything to ask, anything to suggest. More than happy to listen to you.
All right. Thanks a lot, gentlemen. Walter, Razvan, I'll see you guys in about 15 minutes. Átila, have a good lunch. Everybody else, go ahead and take a break. We'll be back in 15 minutes. See you then.